Welcome everyone in lecture number 9 of Laplace Transform. Here in this lecture, we will learn how to find Laplace transform of the function of the type ft divided by t. Means the function is divided by positive integral powers of t. So let me first tell you the rule. If Laplace transform of ft is equal to fp, then Laplace transform of ft divided by t is defined as integral p to infinity Laplace transform of ft. In my lecture number 8, I have told you how to find Laplace transform of tft, right? If you remember the rule, it is defined as minus d over dp into Laplace of ft, right? So here, when you multiply the function by t, the Laplace transform of the expression is derivative of Laplace transform of ft with respect to p. And here, the effect of division of t is in the form of integration of Laplace transform of ft with respect to p. So remember, when you divide the function by t, you have to integrate Laplace transform of ft with respect to p. And the value of this Laplace transform will exist if the value of this integral exists. So I should write here, provided the value of integral exists. तो अगर इस इंटीग्रल की वैल्यू एग्जिस्ट करेगी तभी इस एक्सप्रेशन का लाप्लास ट्रांसफॉर्म एग्जिस्ट करेगा, अदरवाइज नहीं करेगा. Let us take one example. Find Laplace transform of sin a t divided by t. So here ft is sin a t and sin a t is divided by t. So Laplace transform of sin a t divided by t will be, according to this, integral p to infinity. किसका इंटीग्रल? Laplace of ft का. ft here is sin at. So Laplace of sin of at. So this is equal to integral p to infinity p upon, sorry, it is a upon p square plus a square dp. So integration of this is a into 1 upon a tan inverse p upon a. Okay. So whenever you have infinity in the form of a limit, you should not put directly into the expression. You should write like this: limit p approaches to infinity tan inverse p upon a minus tan inverse p upon a. Okay. This implies Laplace transform of sin a t whole divided by t is limiting value of tan inverse p upon a as p approaches to infinity minus tan inverse p upon a. So when p approaches to infinity here, value of tan inverse p upon a will be pi upon 2 minus tan inverse p upon a, and pi by 2 minus tan inverse theta is cos inverse theta. So it is, sorry, cot inverse theta. This is cot inverse p upon a. Okay. Next example is find Laplace transform of cos a t divided by t. Again, we use the same procedure as we have done in case of sine. Laplace transform of cos a t divided by t is integral p to infinity Laplace transform of cos of a t, because here cos a t is ft. This is now equal to integral p to infinity p upon p square plus a square dp. Its integral is 1 upon 2 log of p square plus a square. Again, we take the limiting value of this expression. Log of p square plus a square minus 1 upon 2 log of p square plus a square. As you can see, this limit does not exist. So the value of this whole expression does not exist. Hence, the Laplace transform of cos a t divided by t does not exist. I should write here, since limit p approaches to infinity, log of p square plus a square does not exist. So Laplace transform of cos a t divided by t also does not exist, right? So in this case, as you can see, sometimes the value of integral does not exist. So the value of Laplace transform also not exist. Let me take one different example where the function is divided by t square. Find the Laplace transform of 1 minus cos t divided by t square. Okay. You can think that we have not studied the rule when the function is divided by t square, then how to do it? You can do it by the same rule, by writing this function as one minus cos t divided by t whole divided by t. आप इसे ऐसे लिख सकते हैं. तो आप इसे एज अ होल देखें तो ये दिस इज एफ टी डिवाइडेड बाय टी, इस टाइप का बन गया ये एक्सप्रेशन. तो अब इसका लाप्लास क्या होगा? आप इस पर रूल लगाएंगे तो उसको आप क्या लिखेंगे? p टू इंफिनिटी लाप्लास ऑफ 1 minus cos t divided by t of एंड dp, सॉरी, ऐसे ही लिखेंगे। इस पर अगर आप रूल लगाएंगे एफ टी डिवाइडेड बाई टी का, तो इसको ऐसे लिखेंगे आप। अब we have to find the Laplace transform of this expression. So we mark this as 1 and take this expression as, you can take this as 1. Okay. So 1 is equal to Laplace transform of 1 minus cos t whole divided by t. आप इस पर अब फिर से एफ टी डिवाइडेड बाय टी का रूल लगाएंगे, लेकिन अब एफ टी क्या है आपके पास, इसमें एफ टी क्या है, दिस इज एफ टी। ओके, so this is equal to integral p to infinity Laplace of ft. Ft here is 1 minus cos t. So Laplace transform of 1 is 1 upon p. Laplace transform of cos t is p upon p square plus 1. We integrate this. So it is log p minus 1 upon 2 log of p square plus 1. You can combine these two terms as 1 upon 2 log of, I am coming here, p square divided by p square plus 1 with the limit p to infinity. This is equal to limit p approaches to infinity log of p square upon p square plus 1 minus 1 upon 2 log of p square upon p square plus 1. Its limit is, to find the limit of this expression, divide the numerator and denominator by p square and then apply the limit. So its value is 0 when you put infinity here, and log 1 will be 0. So this whole expression is 0, and this negative sign will exchange numerator and denominator. So this is 1 upon 2 log p square plus 1 divided by p square. This is the value of I. So substituting the value of I from 2 in 1. Okay. Substituting value of I from 2 in 1. What you will get? Laplace transform of 1 minus cos t divided by t square is equal to integral p to infinity 1 upon 2 log of p square plus 1 divided by p square dp. Now we separate these two terms on by the property of log. You can write this as log p square plus 1 minus 2 log p dp. log p square को ऐसे लिख सकते हैं. Now we apply the product rule here. We just take as a first function and into 1 as second function. So we apply the product rule here. Log of p square plus 1 minus 2 log p, this is first function, into integral of second function. Second function is 1 here. 1 का integration with respect to p is p, minus integral of differentiation of this whole. So differentiation of this is 2p upon p square plus 1. इसका differentiation ये होगा, and इस term का differentiation होगा 2 upon p and into p, this term, integration with respect to 1, integration of 1 with respect to p dp with limit p to infinity. This is equal to p upon 2. This p will taken outside with combined with 2 into log p square plus 1 divided by p square, and we apply the limit here, and we solve this expression. When you solve this, you will get p square plus 1 into 2p square minus 2 dp. Let me do it on the next page. Laplace transform of 1 minus cos t divided by t squared is equal to p upon 2 log of p square plus 1 divided by p square with limit p to infinity minus, when you solve this, you will get 2p square will cancel each other, and minus 2 and this minus will become positive, and since 1 upon 2 is also getting multiplied with this expression, this 1 upon 2 is with this also, I should write it here. So this 1 upon 2 will cancel the 2 in the numerator that is left here, and the negative sign and this negative sign will become positive. So we have here plus p to infinity dp divided by p square plus 1. Okay. So this is equal to, when you apply the limit here, to apply the limit, uh, so when you apply the limit, upper limit here, the value of actually we apply limit on these two expressions separately. So we write here limit p approaches to infinity, p upon 2 and log of p square plus 1 divided by p square minus, and lower limit per, this is as it is, p square plus 1 divided by p square, and the value of this integral is tan inverse P. So we have here plus tan inverse P with the limit P to infinity. So limit will apply separately on this as well as this. So limit P approaches to infinity, P upon 2 into limit P approaches to infinity, log of P square plus 1 divided by P square minus, this is same expression, and this value again we'll take the limiting value of tan inverse P and tan inverse P. So now one by one we'll see the limit. This value is infinity, this value is 0, so 0 into infinity is 0. This value is as it is. This value is pi by 2, and this is tan inverse P. So let me do it on the next page. Laplace transform of 1 minus cos t divided by t square will be minus p upon 2 log of 1 plus 1 upon p square. You can write this as 1 plus 1 upon p square plus pi by 2 minus tan inverse p. So this can be written as cot inverse p. You can replace this expression by cot inverse p. So this is cot inverse p minus p upon 2 log of 1 plus 1 upon p square. That's answer. So this is quite lengthy calculation. Whenever the function is divided by uh, powers of t that are greater than 1, so you have to solve it. You have to find the integral of the function too many times. So this is the procedure how to deal with the problems where the function is divided by uh, t square or t cube or t raised to the power 4 and so on like that. So I hope you understand the lecture of today. You can like and share it also, and you can subscribe my channel uh, to get the notification of any new video on this topic. Thank you very much.